And good morning to everybody. I don't know if when you will watch this video, it might not be morning. So, good evening na rin or good afternoon, whatever time you are watching this video. So, uh, previously I have discussed a brief introduction of our course. I hope you have watched that. Now we are going to discuss the first chapter of our course, which is flow rates. So when we speak of rates, there's always an involvement of time. I believe you have discussed time rates before in calculus. So how how this works, time. So when we say rates, it's always in terms of per second, per hour, per minute, per day. Basta in terms of time. Now, since we're dealing with hydraulics or water fluid flow, so basically we'll be dealing with flow rates, especially discharge or volume flow rate. So flow rates can be expressed in terms of three quantities. Number one would be volume flow rate, that is expressed in terms of this formula. So volume flow rate, or Q is, we call this discharge. Q is equal to the product of the cross-sectional area of the conduit. It may be a pipe, a channel, or any conduit, product of the area of the cross-sectional area of the conduit, and the mean velocity. Next would be, it can also be expressed in terms of mass flow rate. Okay, mass flow rate. So by the way, volume flow rate is oftentimes expressed in the units of mga units ng volume flow rate or discharge. This, since we're dealing with volumes, that's cubic meter per second or liters per second, cubic foot per second, and so on. And mass flow rate is expressed in terms of this formula. I hope you have your handouts with you, because we will not be discussing all of the things in your handouts or your modules. This video is just a complimentary lecture video to accompany your module in case you have some difficulties in understanding the module. Then this video might help you understand the different topics in your modules. So every time I make a video, I will make sure that I will make the video as short as possible for you to save data, mobile data, if you're using mobile data or Wi-Fi in accessing this videos. So we'll make it as short and comprehensive as possible. The different definitions and terms that will be used in the course are already in your modules. And let's go to volume. Mass flow rate is expressed in terms of mass. So that would be, the units would be in terms of kilograms per second or slugs per second, and so on. Weight flow rate naman is expressed in terms of weight. Weight, that is in newtons per second, kilonewtons per second, pounds per second, or you can use any unit for time, minutes, hours, days, etc. Okay, so volume flow rate. So from in our course, we will be dealing most of the time with volume flow rates or discharge, especially discharge of water in a certain conduit or channel or pipes. So that's how we compute for the different flow rates: volume flow rate, mass flow rate, and weight flow rates. Okay. Next would be the concept of continuity of flow. What is continuity of flow? Continuity of flow, or the law of continuity of flow, is basically based on the principle, or from the law of conservation of mass, or law of conservation of matter, which state that for any isolated system, for any isolated system close to all transfers of matter and energy, so isolated siya, there's no transfer, okay, of matter or energy, the mass of a system must remain constant over time. As the system's mass cannot change, so the quantity can neither be added nor be removed. So, for example, we have a conduit or a pipe. Merong discharge, water or a certain fluid is flowing into it. So the discharge is going in should be equal to the discharge going out, because the amount of matter that went in through the pipe, okay, is also equal to the amount of matter that's going out, since there's no transfer of mass or matter inside the pipe, or there's no loss of matter inside, right? As the law of conservation of matter or mass indicates. So matter cannot be created nor destroyed, but it can be transformed from one form to another. So it can't be created nor destroyed. So there's no removal or transfer of mass or matter inside that isolated system. So basically, what is going in should be equal to what is going out. If you cut the pipe into two sections, for example, this is section 1 and this is section 2. So the discharge at section 1 is also equal to discharge at section 2. Now, if we have a complex or compound piping systems, for example, we have two pipes in here. One has a larger diameter and one has a smaller diameter. So the discharge at point 1, at pipe 1, is also equal to discharge at pipe 2. So that is the law of continuity of flow. Okay, if later on you have questions, you may raise your questions through our group chat, or you may raise also your questions to MV. You can message me at MVLE if you have questions, or we may also designate a certain time for us to meet online, online, I should say, so that in case you have questions, we will try to address those questions on that particular time. Now let's go to the illustrative problems. Now we have two principles here: flow rates, mass flow rate, volume flow rate, and weight flow rates, and the law of continuity of flow. Now, how do we apply this in our professions? How do we apply these principles or concepts? Now let's go to illustrative problems. I hope you are browsing your modules with you. You may print your modules and you may write into it. Number 1. Let's try to solve number 1. Compute the discharge of water through a 3-inch diameter pipe if the mean velocity is 8.5 feet per second. So when we say 3-inch pipe, okay, the 3-inch here refers to the diameter. So when we designate the size of the pipe, we always there's always in terms of its diameter. So diameter is 3 inches. Yan. And the mean velocity is equal to 8.5 feet per second. Now, mean velocity, we always use the term mean velocity or velocity only. It's mean because, or the average velocity, because the velocity inside the pipe would somehow be is distributed. Let's try to illustrate the distribution of velocities along conduits. So the distribution of velocities, we call it mean because we always compute for the average velocity, because the velocity at each level in the pipe would somehow be theoretically different. So the velocity, let's try to draw the path lines of flow. Okay, so the velocity at this point of the pipe would have to be different. The particles, the particles moving at this point, the velocity of the particles moving at this point of the pipe would be different from the velocities dito sa point na to, here, and so on. Okay, so usually the particles nearer at the wall of the pipe would move slower, okay, because of friction dito. So we try to compute for the average velocity along the different levels along the pipe here, so to represent now the velocity inside the pipe. Okay, that's why it's called mean or average velocity, or velocity alone. So if the problem tells us na sinabi doon velocity, that means it's actually a mean or average velocity. And let's compute for the discharge. So when we say discharge, that refers to volume flow rate. Okay, so volume flow rate is equal to, discharge is equal to area, cross-sectional area of the pipe, and times the average velocity. So it's a simple direct substitution to our formula. So the area, again, you need to look into also although the dimensions are homogeneous, but look into the units used, it should be homogeneous. If kung inches ito, the rest of the terms should be items in the equation should also be in terms of inches, or you may convert inches to feet. Basta there is uniformity or homogeneity of units in the equation. Before you substitute the values to the equation, make sure that the units are homogeneous or uniform. So the area, since it is in inches, I think we need to convert this in feet. So it's a circular pipe. Okay, so circular pipe siya. So the area of a circle would be pi in terms of diameter. The diameter is 3 inches. I-convert natin sa feet. So there are 12 inches in 1 foot. Okay. So cancel yung inches, we're left with feet squared all over 4. So this is the cross-sectional area of the pipe in terms of feet times the mean velocity, which is 8.5 feet per second. So the discharge is equal to 0.417 cubic feet per second. So this would be the answer for number 1. So take note, the first chapter usually deals with the fundamental concepts, which will be used in a more complex situations later on in our succeeding topics. So please, before we go to the next chapters or succeeding topics, at least you should know how to solve for discharge and apply the continuous flow principle, or the law of continuity of flow. Next, let's proceed to the next problem, illustrative problem. Okay, let's proceed to the second problem. Air that has a mass density of 1.24 kilograms per cubic meter flows in a pipe with a diameter of 30 centimeters at a mass rate of flow of 3 kilograms per second. What is the discharge and the mean velocity in this pipe? So we have the following given in the problem. The mass flow rate is equal to 3 kilograms per second. The density of air is 1.24 kilograms per cubic meter, and then the diameter of the pipe is 30 centimeters. We are to solve for the discharge Q and the mean velocity V. Okay, so first, since alam natin yung mass flow rate at 3 kilograms per second, mass flow rate is equal to density times Q, or the discharge, which we are solving. So from this formula or equation, if we try to manipulate this, Q is equal to M, mass flow rate, divided by the density of air. Now, Q can be easily solved. It is given yung mass flow rate natin at 3 kilograms per second and the density at 1.24 kilograms per cubic meter. So kilograms will cancel. We're left with Q at, so the answer would be, please check on the calculations, the solution, the process might be correct in the module, but I might have missed some things during the calculation or input in the calculator, so please try to double check whatever answer is presented, or solution, whatever solution or answer is presented in your modules. Okay, and please notify me if there are some corrections that are. So the discharge is equal to 2.419 cubic meters per second. So that is the discharge in terms of cubic meters per second. Next is we are to solve for the mean velocity in the pipe. So what is the mean velocity? So the mean velocity, based from the formula for discharge, we can compute for the mean velocity. Discharge is equal to the product of the cross-sectional area and the mean velocity. So basically, the mean velocity is equal to Q all over A. So the mean velocity now is equal to, since we have computed for Q a while ago, that is 2.419 cubic meters per second divided by the cross-sectional area given the diameter of the pipe at 30 centimeters. So area in terms of diameter. So again, please look into the dimension or the units used. It should be uniform. Kung centimeter to and the rest is in meters, you may convert this unit in meters so that the contents of the equation or formula is uniform in terms of dimension and units. So we'll convert natin yung 30 centimeter to meter, so that would be 0.3 meters squared divided by 4. So the mean velocity is equal to 34.227 meters per second. So this would be the answer or answers for problem number 2. again, if you have questions, you may raise your questions through our group chat or through MVLE. You may message me, or you may, and we can also again assign or designate a certain time where we can meet online through Zoom or Google Classroom or Google whatever form it is. So let's proceed to number 3 then. Problem number 3. Next, number 3. Let's proceed to number 3. Water flows through a 75 mm diameter pipe at the velocity of 3 meters per second. Find the following. Letter A, the volume flow rate in cubic meters per second and liters per second. Letter B, the mass flow rate in kilograms per second. And letter C, the weight flow rate in newtons per second. So let's start with letter A. What is the volume flow rate in terms of two quantities? That is in cubic meters per second and liters per second. So the diameter is 75 millimeters, and then the mean velocity is 3 meters per second. So we can simply solve the discharge or the volume flow rate by substituting the values for area and the mean velocity. So Q is equal to the area, which is in terms of diameter, that's pi, times diameter is equal to, convert natin yung millimeters to meters, so that would be equal to 0.075 meters square divided by 4. That's the area, cross-sectional area of the pipe, times the mean velocity, which is 3 meters per second. So the discharge is in cubic meters per second is equal to 0.01325. That's a lot of numbers. 25359 cubic meters per second. That is the discharge in terms of cubic meters per second. The problem also requires us to solve it in terms of liters per second. So how many liters in 1 cubic meter? So in 1 cubic meter we have 1,000 liters. So convert na natin to. So mag-move lang tayo ng 3 decimal places. So Q is equal to, so 0.0132559 cubic meters per second. So we have 1,000 liters in 1 cubic meter. Canceling cubic meter, now we're left with liters per second. Or simply move 3 decimal places dito sa may answer natin in terms of cubic meters per second. So Q in liters per second is 13.254 liters per second. Yeah, so that's letter A. Letter B, what is the mass flow rate in kilograms per second? So what is M in kilograms per second? Okay, so we know that M is equal to the product of density and the discharge. So what is the density of water at standard temperature and pressure? So the density of water is equal to 1,000 kilograms per cubic meter. So substitute lang natin to dito, and then the value of discharge from the previous problem. So we have the mass flow rate then is equal to 1000 kilograms per cubic meter times the discharge, which is 0.01325 wow, kilograms per cubic meters per second, I should say. Cancel yung cubic meters, we're left with kilograms per second. So the mass flow rate is equal to 13.254 kilograms per second. Okay. And next, letter C. What is the weight flow rate in newtons per second? So the weight flow rate is the product of the density, the unit weight of the liquid with gamma, unit weight of the liquid, and the discharge Q. So the weight flow rate then is equal to the unit weight of water, again, is equal to reviewed our previous subject, CE 141 or hydraulics 1. The unit weight of water at standard temperature pressure, that's equal to 9810 newtons per cubic meter, or simply multiply gravity dito sa density natin. Okay, so we have 9810 newtons per cubic meter times the discharge, which is, I'll just copy the value, very long. Cancel ulit ang cubic meters, we're left with newtons per second. So the answer is, surprise, what is the answer? Oh no, what happened? So 130.018 newtons per second. So that is the weight flow rate. Okay, very simple, easy, direct substitution from the 2D formulas. Okay, let's proceed to the fourth illustrative problem. This time we are going to apply the law of continuity of flow. Okay, let's continue with problem number 4, second to the last illustrative problem for this particular lesson or chapter. Number 4, a pipe consists of successive lengths of 15 inches, 12 inches, and then 10 inches diameter pipe with a continuous flow through the line of 9 CFS. CFS means cubic feet per second of water. Compute the mean velocity in each size of the pipes. So we are to solve for the mean velocity in each size of the pipe. So we're going to apply the law of continuity of flow. So continuity of flow states that the discharge going in is also equal to the discharge going out of the system. Of course, in reality, hindi ganito yung itsura ng pipe. Ito yung mga mahabang kilometro or hundreds of meters of pipes yan. Hindi talaga siya horizontal, ay siya talaga ganito yung itsura, but liku-liku yan. So kapag nagdugtong-dugtong tayo, sometimes of different sizes or diameters of pipes. And this is just a schematic diagram to represent now yung problem number 4. So applying the law of continuity of flow, so if Q is equal to Q out, then the discharge at point 1 is equal to the discharge at point 2 and is also equal to discharge at point or pipe 3, which is equal to the discharge in the entire system going in and going out. So we can simply solve for the velocities in each pipe. So of course we expect that at a lower diameter or shorter or smaller diameter, the velocities would somehow increase to maintain, of course, the discharge in the entire system. Okay, let's solve for the discharge in pipe 1. So basically the discharge in pipe 1 is also equal to discharge going inside the system, which is equal to 9 CFS. CFS means cubic feet per second. So that is CFS. If you meet this unit for discharge later on, CFS means cubic feet per second. So Q1 is equal to this is also equal to Q1. So if that is Q1, substitute natin sa equation of discharge sa may pipe 1. So Q1 is equal to cross-sectional area of pipe 1 times the velocity in pipe 1. So that is 9 cubic feet per second is equal to the area at pipe 1, which is in terms of diameter, giving diameter na 15 inches. Again, inches ito, i-convert natin sa feet para maging uniform yung units natin. Okay, so what is the area? So that is, in terms of diameter, that's pi times 15. Okay, let's try to make it larger. So pi times 15 inches. Convert natin sa feet. So we have 12 inches in 1 foot squared over 4 times the mean velocity, which is the unknown in this particular problem. Now we have the value for V1 that is equal to 7.334 feet per second. Next, the same is also true sa pipe 2. So for pipe 2, so Q2 is also equal to the discharge of the entire system that is equivalent to 9 cubic feet per second. So if that is the case, 9 cubic feet per second is equal to, should be equal to, Q2 is equal to area 2 times the velocity at point 2. Basically, we are solving for V sub 2 there. So we have the pi times the diameter in feet. That is 12 inches. So there are 12 inches in 1 foot, so that's basically 1 foot. In this case, squared all over 4 times V2. So the velocity at point 2 is 11.459 feet per second. And lastly, to compute for the velocity at point 3, so Q3 is equal to area 3 times the velocity at pipe 3. Q3 again is equal to the discharge in the entire system, which is 9 cubic feet per second. That's equivalent to the area at point 3 times velocity at point 3. So area at point 3 is equal to pi times the diameter in feet. So we have 10 inches. We convert natin sa feet. So that we have 12 inches in 1 foot squared all over 4 times the velocity at pipe 3. So the velocity at pipe 3 is equal to 16.501 feet per second. Okay, so V1, V2, V3, we have solved for their values. That's how we apply the law of continuity of flow. Okay, so let's proceed to the fifth and last illustrative problem for this particular chapter or topic. Alright, let's proceed to the fifth and last illustrative problem for this topic or chapter, number 5. Water flows steadily through a closed tank. The schematic diagram is shown in your modules. I have drawn the diagram also, but yeah, kasi magkaparehas. Anyway, okay, at section 1, this section, the diameter of the pipe is 6 centimeters and the volume flow is 100 cubic meters per hour. So the arrow indicates that at section 1 the flow is going inside the tank at 100 cubic meters per hour, and at section 2, at this section, the diameter of the pipe in here is 5 centimeters and the average velocity is 8 meters per second. So again, the arrow indicates that the discharge is going out of the tank. Okay. If the diameter at the section 3 is 4 centimeters, what is discharge in section 3 in cubic meters per hour? And the average velocity at section 3 in meters per second. Okay. So first we need to convert all units to be para maging uniform yung mga equations or formulas natin later on. Okay. So at section 1 we have, so let's solve first for letter A. What is Q3 in cubic meters per hour? So first thing we should do is to make all units uniform. Yung at section 1 kasi the discharge is in cubic meters per hour. Maybe it is more convenient if we convert that to cubic meters per second. So Q1 is equal to 100 cubic meters per hour. So in 1 hour we have how many seconds in 1 hour? It's 3,600 seconds. So Q1 is equal to 0.0278 cubic meters per second. That is Q1. And since the velocity at section 2 is known, the velocity at section 2 we have the average velocity is given at section 2. So maybe we can solve for the discharge at section 2 since given naman yung diameter and the velocity at section 2. So we can easily solve for the discharge at section 2 by simply multiplying the area at section 2 and the average velocity at section 2. So Q2 is equal to area at section 2 in terms of diameter, that's pi, times 5 centimeters. Convert natin sa meters. Kaya mag-move lang tayo ng ilang zeros or decimal place. We have 0.05 meters square all over 4 times the velocity, which is 8 meters per second. So the discharge in section 2 is 0.0157 cubic meters per second. Okay, now let's go to section 3. So section 3, we are to solve for the discharge and the average velocity. How do we solve for the discharge and the average velocity? So let's first solve for the discharge. So how do we solve for the discharge at section 3? Now, from the law of continuity of flow, there are two possible conditions here. Since at section 3, we do not know if the discharge is going inside the tank or outside the tank, there are two possible conditions here. So it's either Q1 plus Q top, para maintindihan natin yung underlying principle. So from the law of continuity of flow, we know that the Q, or the discharge going in, should be equal to the discharge going out of the tank. Okay, so we know that at section 1, it's going in. At section 2, it's going out. So there are two possible conditions here. It's either Q3 is going in or Q3 is going out of the tank. So there are two possible equations here. So Q in natin is Q1. It's either Q1 plus Q3 is equal to Q2. So kapag Q3 is going in, okay, both Q1 and Q3 are going in, then Q1 plus Q3 is equal to Q2. Ano? And if Q3 is going out, then Q1 is equal to Q2 plus Q3. So if Q3 is going out, so Q2 is going out. No? So this is going out, this is going out, this is going in. Q1 is obviously going in. Okay, so all in equals all out. So there are two possible conditions here. So how do we know if Q3 is going in or going out of the tank? So how do we know that? So we can logically know if Q3 is going in or going out of the tank by simply comparing the values of Q1 and Q2. So Q1 and Q2. So if Q1 or if Q2 is less than Q1, let's see, if Q2 is less than Q1, what does that mean? So pag mas maliit yung value ng Q2 sa Q1, that means that Q3 is going in. Q3 is going out, should say. Medyo naguluhan na ako. Okay. That means Q3 is going out. So if Q2 is less than Q1, that means Q3 is going out of the tank. Ibig sabihin, yung masyadong marami yung yung pumapasok, no, mas maliit yung Q2 compared sa Q1. Ibig sabihin, yung excess nun, if you subtract that, yung excess nun, dapat lumalabas din siya to satisfy the law of continuity of flow. No. If Q2 is less than Q1, then definitely Q3 is going out of the tank because yung excess nun, since masyadong malaki yung pumapasok, hindi kayang ilabas ng section 2, definitely at section 3 kailangan lumalabas siya. Ano? So, lumalabas dapat yung discharge doon. And, if Q2 is greater than Q1, then definitely Q3 is going inside the tank. No? So, ito. So, ibig sabihin, mas malaki yung Q2 compared sa Q1, pumapasok yan, saan kukuha ng additional discharge out of the tank? Siyempre dun sa section 3. So, kung mas malaki ito compared dun sa section 1, then ibig sabihin, yung discharge dito ay papasok to satisfy again the law of continuity of flow. So, we have solved for the two discharges kanina, Q1 and then Q2. So, compare natin. Is Q2 less than Q1? Is Q2 greater than Q1? So, in this case, Q2 is less than Q1, which means Q3 is going out. Now, which equation? Saan na yung equation natin? Ito, yung equation natin. So, Q1 is equal to Q2 plus Q3 so that we can solve for Q3 in this equation. So, by manipulating the equation, Q3 is simply equal to Q1 minus Q2. So, Q3 now is equal to Q1 is 0.0278 cubic meters per second minus Q2, which is 0.0157 cubic meters per second. So Q3 is definitely equal to, let's see, the answer is 0.0121 cubic meters per second, but the problem is asking us to solve it in cubic meters per hour. So i-convert natin ito. So in how many seconds in 1 hour? We have 3,600 seconds in 1 hour. Okay, cancel yung seconds natin. We have cubic meters per hour. So Q3 is equal to 43.56 cubic meters per hour. And the average velocity at section 3, so Q3 is equal to, so letter B pala to. Letter B, so Q3 is equal to area 3 times V3. So we have, so V3 is equal to, we should be using the one in terms of cubic meters per second, since the problem is requiring us to solve it in meters per second. So we use this value, 0.0121 cubic meters per second divided by the area. Area is pi times the diameter at point 3, 0. Let's see, this parenthesis na lang. 0.04 meters. Oh no, wait lang. 0.04 meters square divided by 4. So the average velocity at section 3, I forgot to include that in the module pala. Wala pala dito sa module. Okay. Let me just solve it. Let me look for my calculator. Okay, the answer is 9.629 meters per second. So that's it. That's the solution for problem number 5. That's how you apply the law of continuity of flow, which is basically or generally based on the law of conservation of matter or law of conservation of mass. So that's it. I will be giving you exercises to solve. I will be posting it in MVLE. So wait for the next video for chapter 2. Okay, God bless everybody.